Hello, in this problem we're going to be talking about friction and kinematics. We're putting the two together again. So friction, there's two types of friction. There's kinetic, and I think in this problem we do have kinetic because we're moving, but regardless of whether it's kinetic or static, there's a coefficient of friction as well as the force normal that gets multiplied together to give us the force of friction. So this coefficient of static friction is, I think, what we're looking for. And yes, coefficient of, sorry, not static, kinetic friction between Daniel's toboggan and the snow. So let's go ahead and see what's going on. So this guy, Daniel, he's tobogganing in the snow. I'll use blue because that's what winter is all about. He comes to the bottom of the hill. That's him right here as a box. He then travels a certain distance and then comes to a stop. So that's him right here. The distance that he traveled is 14.6 meters. The final velocity of his is going to be 0 because he comes to a complete stop. That's what the question says. He starts. So when he gets to the bottom of the hill, he is traveling. So that's his initial velocity. Oops, but initial velocity. And that is equal to 6.5 meters per second. Meters per 6.5 meters per second. So I need to figure out coefficient of kinetic friction. And in order to figure out the kinetic friction here, before I can figure that out, I really need to figure out acceleration. And that's really what connects. So acceleration is really one parameter that connects friction or forces, any kind of forces, with kinematics, right? That's really the bridge between the two. So I can utilize this kinematic information that I'm given in order to figure out the acceleration that Daniel is going at during this first part of the trip. So one of the formulas, I mean, you've got 5 formulas for kinematics, and you really need to figure out which one you're going to use. And if you take a look at your list of 5 equations, one of them is velocity final squared is equal to velocity initial squared plus 2 times acceleration times displacement or distance traveled. And that's the one that I really want to use because I've got those variables and I'm looking for acceleration, right? Acceleration is really a question mark here, and I can find it. I've got the other 3. Final velocity is 0. Initial velocity 6.5 squared plus 2 times acceleration and the distance that I travel, which is 14.6. Awesome. I'm just going to use my calculator here and move things around. So 6.5 squared is 6.5 times itself is really 42.25. I'm just going to move it over to the other side. I know I'm going to have to do that eventually. And that's really equal to 2 times 14.6, which is 29.2 times acceleration, dividing both sides by 29.2 will give me a certain value. 42.25 divided by 29.2 will give me an overall acceleration of negative 1.45 meters per second squared. And that's fantastic. It's negative because I'm slowing down. That makes sense. So now that I know my acceleration, negative 1.45 meters per second squared, now I can go ahead and figure out my forces stuff, right? And I'm looking for the coefficient of kinetic friction, but as I'm moving, I can kind of draw my my free body diagram. As I'm coming to a stop here, I'm going to erase everything else. Here's my free body diagram of Daniel and his toboggan. And it is, the mass is 95 kilograms. Of course, there's the normal force acting on Daniel as he's at the bottom of the hill just sliding. There's the force due to gravity, and the sum of these forces is 0 in the y direction. You should appreciate that because he's not moving up or down. He's only moving to the left or right. Now, the force that is acting on him is this force of friction in the horizontal direction. Nothing else acting on him in the horizontal direction. Nothing is pushing him forward because he's just coming to a stop, right? So there's no indication of other forces acting in the horizontal direction except this force of friction. So if I want to use Newton's second law of motion, I can say force net in the x direction is really equal to mass times acceleration. I know what his mass is, and I do know what his acceleration is. I just figured it out in the previous question, so that's fantastic. I know that. I know that. I also know force net in the x direction is really just force of friction, right? So I can really figure out what the force of friction is by plugging in my mass, which is 95 kilograms, and the acceleration, which is negative 1.45 meters per second squared. And we can just do, again, quick calculation to figure out what that is. 95 kilograms times 1.45. And that is equal to 137.75 newtons. It's negative because it's acting in the opposite direction of movement, and that makes sense. Now, I also know that force of friction, I have my formula for the force of friction, and that's really equal to the coefficient of friction times the normal force. And that's great because I know what the force of friction is. I know what my normal force is. It's actually equal to force due to gravity. We've said that already in the beginning. And force due to gravity is nothing more than mass times acceleration due to gravity, which is 9.8 meters per second squared. So I can say, well, my force of friction is negative 137.75, and that's equal to mu, which is really what I'm looking for, times force normal, which is really my mass, 95 times 9.8. And if I just do quick calculation, 95 times 9.8, that calculation is 931. I'll divide both sides by 931, and it's going to be 137.75 divided by 931 newtons. And in fact, the coefficient of static friction is dimensionless. I don't need a negative in front of it. The negative was just direction. It's required for vectors, but we don't need it for the coefficient. The coefficient of static friction is 0.148. And again, that's a dimensionless unit. It is my coefficient of kinetic friction of this toboggan.